In this video, we're going to talk about molecular mass, which is the mass of a molecule. In the next video, we'll talk about moles, which is a unit that we use to describe the number of atoms or molecules that we have. And in the video after that, we're going to talk about molarity, which is a unit of concentration that describes kind of how many atoms or molecules of solute you have per liter of solution. All three of these videos tie together. So I just wanted to give you a roadmap before we get started. And before we talk about molecular mass, let's quickly review atomic mass. So if you want a more thorough review, go back to chapter 2, part 1. That video covers atomic mass, I think. But we'll review it here. So the mass of an atom is equal to the number of protons and the number of neutrons in that atom's nucleus. A proton or a neutron, either one, would have a mass of 1 Dalton. So when you add them all together, you get the mass of the atom. Remember, the mass of an electron is so small that we say it's negligible. We pretend it's 0 and we don't worry about it, at least for our purposes. And the atomic mass is included on the periodic table. So this is sodium. And sodium has an average atomic mass of 22.990. Sodium every atom of sodium has 11 protons. Remember, we said that every atom of an element has the same number of protons. So for sodium, that's 11 protons. But then different atoms of sodium can have different numbers of neutrons, and those are different isotopes of sodium. So those atoms have different molecular masses, even though they're the same element. And the atomic mass here of 22.99, you can see it's really close to 23. So the vast majority, apparently, of sodium atoms have 11 protons and 12 neutrons. And so they have a mass of 23 Daltons. But there are going to be some that have slightly more neutrons or slightly fewer neutrons. And so when you take the average mass out of all of the atoms of sodium, you're going to get 22.990, which is just slightly less than 23. So when we're talking about molecular mass, it's really similar to atomic mass, but it's for the whole molecule. So the molecular mass is the sum of the masses of each of the atoms that make up the molecule. For example, if you just looked at hydrogen gas, H2, that has 2 atoms of hydrogen. Each atom of hydrogen has a mass of 1 Dalton. We can round for our purposes here. We'll just say 1 Dalton. So the molecule H2 has a mass of 2 Daltons because it has 2 hydrogens. So go ahead and try this one. What is the molecular mass of H2O? And you might want to pause. So oxygen, 1 atom of oxygen has a mass of 16 Daltons. 2 hydrogens have a mass of 2 Daltons total. So all told, H2O has a mass of 18 Daltons. How about NH3? So 1 atom of nitrogen has a mass of 14 Daltons. 3 atoms of hydrogen have a mass of 3 Daltons total. So 14 plus 3 is 17 Daltons. And here's a bigger one. What is the molecular mass of glucose, which is C6H12O6? So pause if you need to, because I'm going to tell you the answer. It is, so if you have 6 times 12 for carbon, that is 72 Daltons. Then you have 12 times 1 for hydrogen, that's another 12 Daltons. And then 6 times 16 for oxygen is 96 Daltons. And if you add those 3 numbers together, you get 180 Daltons as the molecular mass of glucose. When you're working in lab, if you're working with a substance, you can figure out the molecular mass using the periodic table, like we just did. For example, this is sulfuric acid, which is H2SO4. You could add up the masses of all the atoms, but usually the molecular mass is conveniently written on the label. So here it says MWT, that's molecular weight, 98.08 grams per mole. That's kind of another way of writing Daltons. So it's 98.08, and you don't have to do the math, so that's nice. but you can always do the math, double check too.